Hello, my name is Kanab Shala. I will go through my code which I've written. I used two models, KNN and SVM. Okay, and for that I have used a few important libraries: sklearn, Torch, uh, and then we have a Torch Vision, TensorFlow for data set, sklearn for the model and the matrices, and then we have used the SU QML. Okay, basically CUDA based library where you perform all the machine learning tasks on GPU. Okay, normally all the machine learning models are being processed on a CPU. So for that, I have used a GPU based library which gives the support of a GPU if you want to load the model on GPU. Okay, and yeah, I will go through each function by function. This function pre-process data. First, it will convert the data from RGB has a three channel. Means RGB says that it has three channel. It contains a value from 0 to 25 to 55. Okay, so what it will do, it will convert the data from 255 to 0, means from range from 0 to 255 to 0 to 1. Then we have, I will go through the both function, apply variance threshold and apply PCA. This both are feature selection. A variance threshold will basically try to remove the features which are below the thresholds. Basically, whose variance value is below the threshold, it will remove those features, and so eventually it will help in inferencing and means reduce the inferencing time and better accuracy. Same for PC also. Here we have tried said that please maintain 0.95 percentage of selection. You can means you can perform on 95 percentage of data, but means don't remove the whole 95%. Try to work on those 5 percentage where you want to do some calculation and try to come up with new feature, which is the combination of all the removed feature. Okay, so it does not lose the vital information. Then afterward, we have a train and evaluate model. This is a function which is going to evaluate the model, and it is going to send the dictionary which contains the important matrices, accuracy, precision, recall, F1 score, confusion matrix, and training time and inference time. Okay, this is important. These two features are also important. After that, I have used this elbow method. Elbow method is used for finding the best key or for which the accuracy is good, means is the best. Okay, so how create a bin from 1 to 20 and it tries to find the best value of a key out of it. Okay, and here I use the threading based approach where it tries to parallelly execute 10 threads. Basically 10 processing can be parallelly executed. So for k equals to 1 to k equals to 10, it will try to parallelly calculate the accuracy for it, and then it will plot the data on the graph, and then we can find out which k it has produced the best value, best accuracy value. And after that, there is one more function, run experiment on KNN, which is the main function. Basically, it, as I mentioned in the function description, it will try to execute elbow method, find the best key, and using that best key, it will find the all the vital information like confusion matrix, accuracy, F1 score, and then in the next step, it will try to calculate the features. It will try to do feature selection using variance threshold in the step two, and the third step, it will try to calculate PC, means accuracy after doing PCA based feature selection, and lastly it will generate it will display the table for which contains the average accuracy and average variance threshold value. I mean average accuracy, average FN score, all the important matrices, so we can compare the results easily. And then also it will also plot the confusion matrices, so it makes means for comparing for finding out which class is getting misclassified as the most means, and for which class it is being misclassified from. Okay, so vice versa, we will be able to get the information like what could be the basic reason, what could be happen there. Okay, and after that, we yeah, these are the basic steps where we load the data, we pre-process the data, and then we feed it to the main function where it will generate, as I told you, it will generate this elbow graph where we will find out the best k value, and after that it will generate the table, after generating the table, it will go for the confusion matrix, and from confusion matrix we can find out for which class it is being predicted from, very means which class is being predicted, being most misclassified. Okay, so yeah. So, and after that, yeah, this is for CFAR. First one was for MNAST, and second one was for CFAR. Okay, CFAR is quite complex. So yeah, we can see there is a clearly there is a only we were able to find out only 0.3 power means 35-36% of accuracy at max. Okay, after doing PC and also. So yeah, from this we can see that model get hallucinate when we try to feed a harder example to it. It can be, I have mentioned that it is due to most of the time it is due to the image quality also matters when we try to train the model. Okay, then the most important step, I have also introduced a feature extraction using CNN based model. Here I have used the ResNet 50 and then gap feed it to the KNN. So if you see this function, it will try to get the model ResNet 50. Okay, this particular line will basically, instead of generating the results, it will give the feature map directly as output, and then feature map can be used as a input to the KNN. So if you see, we are getting the batch wise feature map for the image. We can go for single one-to-one image and then try to calculate the feature map. It is going to take time, so that's why we need batch wise, and it is going to operate on mostly GPU. If you're going to use CPU, it is going to take time. Okay, and then after that, we'll get the features, and using that features we are going to experiment. We are going to run the same function that we have used earlier to find the accuracy and precision score. And yeah, using this method we were able to find out 90% accuracy on CFAR data set. This is far as far the most accuracy we got through. We got through the after implementing the KNN, let's say, best accuracy we got till now. Okay, but yeah, it says that convolution neural network are quite proficient in getting the classification task done. Okay, and then we will go for the SC, as I already mentioned. SVM, I struggle a lot in SVM because SVM is very hard. It's not very hard to implement, but it takes time to get trained. Okay, so for that, I have introduced a CUDA-based SVM structure, which will load the data into model. So it will reduce the training and inferencing time quite a lot, like very very low. Okay, so that's why I used that Kudabis library for SVM. And yeah, I have tried to do, this is the fun function which will as mentioned in the steps, we will try to find the best C value. I have a bin of this 4 value where I use the 0.1 as the less strict value and 100 as the most strict value. Most as the C gets stricter, it model will try to get overfitted. Okay, and if the C value is 0.1 means less, it is going to, model is not going to get overfitted a lot, means so it's vice versa. If you put less C value, it is not going to overfit, but it is not going to be good at accuracy. Okay, so yeah, we have to choose wisely the C value. And after that, we will get the bar graph that shows the accuracy. Y-axis will show the accuracy and x-axis will show the C value. Okay, and then after that we will, as mentioned in the steps, we will go to the basic step. First we will calculate the using the original feature and the best C value. We will get all the vital information, all the important matrices, and then we will try to calculate the variance threshold. Okay, using variance threshold we try to calculate the accuracy, and then using PCA we try to calculate the accuracy, and then we display those information in table format. This table will contain the average accuracy. Okay, for average accuracy it means that for each of the class weighted accuracy. So if you have a 3 class, and for 3 class it will have some accuracy, and it will try to do x1 plus x2 plus x3 by 3. Okay, and then it will try to plot the confusion matrix for all of the steps for which we have tried to calculate the this accuracy, like using variance threshold, using PC, and without using any feature selection. Okay, so yeah, you see, we ran this function and we were able to plot this bar graph. And for MNSD dataset, we got the highest accuracy 90.12, which means 90.28, which is far more means which is nearly 6% higher than the KNN based architecture. And then confusion matrices for all of them. And then for MNIST also, it has outperformed the KNN. It was able to get 0.56% accuracy, whereas KNN was only able to achieve 0.3% or 37% accuracy. Okay, so yeah, it says a lot, but yeah, from this, I was able to analyze that yeah, KNN based architecture is not that great if you don't have a support for feature extraction through CNN, convolution neural network. But SVM is quite dull, and what means it takes a lot of time for training, okay, and inferencing. So if you want to get an edge-based solution, then you need to rely on KNN. And if you want a cloud-based solution where accuracy matter the most, we can go for SVM. So yeah. Okay, so in this video we have discussed four things. First, feature select means first normalization of data. Second, feature selection. Third, the important methods means elbow method, and the best C value selection for SVM. And then we try to go for the feature extraction using CNN on KNN model, machine learning model. Okay, bye.